Well, we're here with Dr. Tom Valone from the Integrity Research Institute, located in Washington, D.C., to talk about STAIF 2006, his presentation on the Jefimenko Equation, the Biefeld-Brown Effect, and a number of innovative trends in a really popular area of reactionless drive research. Well, Tom, I guess I should start out actually with the Jefimenko equation, because I think that was the real stunner to your research. Now, this is in your book, Electrogravitics II. You have an enormous section on this, but this seems to almost be kind of the stepping stone from the conventional low-efficiency lifter to something that could potentially be much higher in output.
That's true, Tim. In fact, the equation is so simple that Jefimenko was surprised that he really didn't get more response from it years ago. But he picked the right name for it, Electrokinetic Equation, and the electrokinetic field. The strange, interesting synchronicity here is when I wrote to him about the name, the use of that word in connection with Townsend Brown and the Biefeld-Brown Effect, Brown named a number of his patents, electrokinetic apparatus, electrokinetic transducer, and I wondered if Jefimenko had known that.
Sure.
And he said he didn't.
Oh,
he
okay.
Wrote back in writing saying he had no idea. So here's a synchronicity in time of similar technologies or similar ideas manifesting in two different ways. And certainly he provides the tool for any pulsed current device.
Now, in terms of the way that the equation actually describes it, in your presentation, if I remember correctly, you described this as being a direct gravitational electromagnetic coupling to some degree, right?
Well, no, it's electrokinetic. In fact, that's why I tried in my presentation to separate the two concepts.
Oh, okay.
This is something Brown did, and he assumes that other people sort of understand that, but Brown never really published very much. So what you find is that in the first patent, and this is really due to Thomas Bader, I give a lot of credit to him. He's the first article after mine in the book, and he's from the Army Research Lab. And what he points out in terms of the history that he delineates in several pages of his article is that as you go through the patents, you see the British patent, I think it's 300,311, that particular one from 1920-something is the only one that refers to gravity or gravitational effects. From then on, he simply talks about electrokinetics, and that's where mass is no longer important.
Now, these are all aspects also in Electrogravitics II, the book, which you sell through Integrity Research Institute online.
It's on Amazon too.
Oh, okay. Well, actually, could you give us your URL for the audience to visit?
Sure, it's integrityresearchinstitute.org.
Oh, awesome. Okay, so in terms of the book then, the research presentation you did contains a lot of elements from the book, but you have things like very, very good detailed equations for your standard Biefeld-Brown or lifter thrust. And I guess the results from Bader and Fawzi, if I remember correctly, the Army Research Lab, those match your equations pretty closely, don't they?
Well, what Bader and Fawzi found were specifically the null result from ion wind. That was 3 orders of magnitude too small. So even though years ago the Office of Naval Research made just a passing dispensing of Brown's effect, saying that it's simply ion wind, when you actually do the calculations as Bader does, you find that the numbers are too small.
Oh.
So the ion drift concept, and to me, I have to admit this, and many people, you may not even think of them as any different, but see, ion drift really is slow-moving ions. And you find that in a number of cases where you have plasma or charge accumulation, like a cloud, around an electrode. So there's drifting involved, but it's not ballistic. And so you have a different set of equations, and when you deal with the electron mobility or, say, nitrogen ions, which is what you find in air, 80% of air, it's the nitrogen ions that are actually contributing to the Biefeld-Brown lifter effect.
Yeah.
The static high voltage.
Well, and I guess it may be perceived in kind of with some negativity by the audience in terms of people who are hoping that these equations, the standard equations, will give them some kind of a magic bullet to improve efficiency. But if they're predicting what we're already seeing, then that would indicate that these devices, the contemporary lifter or the contemporary Biefeld-Brown, is pretty close to where it should be, right, in terms of the equations.
It seems to be at an optimal stage as far as how much that art or science could be improved upon. So I think, and this is where I really have done more digging in terms of the electrogravitics material and Honda's research in that, which is 10 years old now. They have some interesting theory, plus they actually seem to show that there is some correlation to their experiments. But when you start pulsing a lifter or electrokinetic type of asymmetric capacitor, there's, I would say, an order of magnitude improvement in the lifting capability.
Now, what do you think that would take us from? Because right now we seem to be in the grams level for your average run-of-the-mill lifter, lifting, I think the average is 5 to 20 grams. 20 would be more on the large side. But what do you think that the Jefimenko equation, with a little bit of tweaking and a fair amount of legwork to engineer it, what do you think that might take us to in terms of efficiency?
Well, it's very likely that you'll be seeing things in the hundreds of grams and higher, even with the same geometry.
Oh, okay. So even with just marginal improvements, really just working on the sawtooth wave itself, then you can boost thrust. Mm-hmm. Okay, and then I'm sure that this equation over time might also lead to some new concepts that could further move things forward.
Absolutely, and geometry, of course, can be improved as well.
Well, some of the other things that you covered in the book, one of them was Paul LaViolette, Dr. Paul LaViolette's hypothesis about the B-2 bomber. Now, you went in depth into this, and I was surprised that you had mentioned Northrop's unclassified research relating to boundary layer reduction on the wing surface. Mm-hmm. Can you tell us a little bit about that?
Well, it's been reported from a number of sources, including Paul, when he dug into it for his paper that's in Electrogravitic Systems, Volume 1 I call it. He found that Northrop was willing to admit that their research in electrifying the leading edge of the wings was only for laminar airflow and turbulence reduction. So that boundary layer research, they claim, has already been done, and you find, as I showed, the original diagram from 10 years ago from Northrop for the B-2 shows the leading edge ionizers actually, in that case, they were blackened and separated by actually separations on the leading edge itself. So they're very clearly marked and visible even from the ground.
Yeah. Well, another thing that you mentioned was depleted uranium stripes on the front of the wings. Mm-hmm. And I guess I've heard two conflicting stories about what that might be. The first might be that it would be some kind of a high K dielectric. Mm-hmm. But the second was, I've heard rumors about people experimenting. In fact, I think one of the national labs was supposedly experimenting with depleted uranium for a stimulated nuclear emission. Basically, on high voltage, they thought that it might break down a little faster and emit its own energy. Have you heard about any research like that?
That delves into a different topic of transmutation of nuclear waste, but yes, I have heard that.
Yeah, I think it was, and you're well-versed, actually. And again, Integrity Research Institute has done a lot of work with Paul Brown's research, and that connects to that.
Right.
So, well, in terms of some of the concepts that we saw this session, what are some of your favorites? What are some of the ones that you've maybe thought about pursuing in the future, or at least keeping a close eye on?
Oh, I think that Jamie Childress' presentation on the parallel magnetic motor was actually very interesting. I hadn't seen the presentation before, and I understand that the inventor has had some history behind his promotion of that invention. But to find their support for just having two magnetic circuits, paths in other words, instead of just one, I had no idea it was so simple.
Yeah.
And such a improvement in energy efficiency.
Well, that and you know, in addition to it being peer-reviewed, having a peer-reviewed paper submitted, Childress himself is a very, very rigorous engineer. He's a senior engineer over at Boeing. So I think that adds a lot of weight to his recommendation for the Flynn motor.
Right. Absolutely.
So, well, you know, one of the things that I was kind of surprised by was this upswell in interest and just some amazing presentations to the Woodward effect. Do you have any thoughts on where that's going or if it's going?
I wonder if it's going. Even after talking about Woodward about it, he claims that the very noisy signal that we saw, which for some unknown reason has not even been computer smoothed or signal to noise ratio improved, he claims that that's 50% of what theoretically he should have.
Oh,
so
okay.
He's right within the order of magnitude he expects, but the signal is so bad that you wonder if there's any effect there at all. And then another researcher with even a bigger vacuum chamber and lots more financing reports that even if he turns off the magnet, he's still getting an effect just from the capacitors. And that's where I perked up, because when the audience starts asking, what effect can you get from voltage on capacitors, I just said, hey, see me talk the next day, because these guys are clueless.
Oh.
They haven't seen electrokinetics or even looked into that area. And so you can literally have in nature two conflicting phenomena that perhaps are contradicting or opposing each other. And so I'm at least suggesting to Bob, instead of off-the-shelf capacitors, or if you have to use off-the-shelf capacitors, at least orient them to the horizontal or 45 degrees, so you can maybe at least test to see if there's some electrokinetic vector.
Oh, sure.
Contribution.
Well, now, do you have any thoughts on some of the papers regarding wormholes and the Alcubierre drive and some of the more esoteric and much more expensive concepts?
Yeah, and that's exactly what they are. They're very interesting, but they are expensive. And certainly the topic of creating wormholes and the theoretical presentations we saw, Eric Davis stands out in my mind. The Institute for Advanced Research obviously has got a good handle on a lot of that physics. It's a lot more feasible than I ever expected.
Yeah, I was actually surprised by that also. And again, if there is anything to the Woodward effect, there's also this idea that perhaps they're generating a negative mass that could maybe someday stabilize a wormhole throughout, which was also kind of a remote but interesting possibility. Mm-hmm. Well, I'd like to ask, you're back at the patent office now, right? So that's the day job. But how is the Research Institute itself going? Is it moving along pretty well? Are things picking up?
Well, actually, I don't have as much time as I did before to devote to, for example, even finishing my next book on the zero-point energy, fuel of the future. Because that, to me, is a very important layperson's book to really become more aware of this field. But, in that particular area, as it is with some of these other emerging technologies, what I find is that as I wait, more and more contributions from the journal articles are starting to appear.
Yeah.
So I'm convinced, as I was 10 years ago with electrogravitics, that this is an emerging field, cannot be stopped, and it's really a futuristic goal for humankind. I mean, this is like the manifest destiny. So as I wait, things only get better.
Oh, absolutely.
And then I have more resources to put in the book, and perhaps even more notable sources that are even more closer to what I feel are the goals that we'll reach very soon.
Well, and speaking of which, in terms of, I guess, growing acceptance, not only for breakthrough propulsion, I think, but also for energy technologies, you've been doing more media work recently also. As I recall, I've seen you a few times on major networks speaking about renewable and green energy sources. So
that could be. I know they use some of my interviews and piecemeal them into various shows.
Well, in terms of the website, the Integrity Research Institute itself, have you thought about adding or modifying the site at all? I mean, just as time progresses, adding multimedia features or anything along those lines?
Sure. Yeah, I'm happy to improve the website. I just haven't devoted much time, energy, or money to it, but it's certainly open to negotiation.
Yeah, well, and I guess I should point out that IRI is a nonprofit, right? Mm-hmm. So the donations and selling books and the tapes and the other materials that you sell, that helps support your research, that helps move these things forward.
And also it helps make the next conference in September, a conference on future energy, a lot more visible and attractive.
Yeah.
Because we'll be able to advertise.
Well, and in terms of moving forward for future conferences, are you going to be presenting many of the same ideas with just a few subtle additions, or are you looking at some very different new concepts going into the year ahead?
Well, I usually try to pick themes that I feel are on the cutting edge. So, for example, we had a Tesla conference in 2003, just when there was a centennial of the Wardenclyffe Tower.
Oh, okay.
And what I found was no one in the world seemed to have noticed that this was a centennial of lifetime proportions. So only once in a lifetime do you get something like that to even think about it. And of course, it's a very controversial topic. And so at least I put together a book called Harnessing the Real Work of Nature to give credit to all the people that have contributed to really Tesla's concept of wirelessly sending powered level energy throughout the world.
Yeah. Well, to touch on energy topics for a minute, because you have spoken at length on those in the past, aside from the breakthrough propulsion arena, what are some of the main concepts that have kind of caught your eye with breakthrough in renewable energy sources recently?
Well, in the renewable area, certainly we have a long ways to go even to make wind energy, for example, more practically available to the general public. I've come across, for example, a community called Angels, I think it's angels-nest.com or .org, and Victoria Peters has a poster and various material on their website that really shows an example of how a self-sustaining community could function and use hydrogen as a fuel. They have their Darius rotor windmill actually doing the power generation for electrolysis and then storing the hydrogen separately. So renewables are certainly coming along slowly, but without tax breaks devoted in that direction, I think we're still going to see a long time before they start to really move fossil fuels out of the way. What I'm really looking forward to, and I firmly believe will start to happen soon, is a standalone generator of some breakthrough nature that allows people to literally be self-supporting and independent, either in the home or business.
Yeah. Well, and
zero-point energy or magnetic motors, those are the areas that seem to be on the cutting edge.
One of the presentations that we saw was Dr. Eric Davis speaking on, this is actually the first real application I've seen that may involve Casimir force, but apparently this was two plates that suppressed the energy in a flow of hydrogen and apparently liberated energy from that in the process. Do you think that that's an experiment that we'll see conducted, and do you have any thoughts on how feasible it might be?
With his parallel plate design, I'm not sure. Actually, that to me was more designed to shield out certain frequencies and to create the Casimir force in a cavity. But there's a very interesting set of different scenarios that can be followed when you try to engineer the zero-point field with the tools that I call a toolkit. In fact, that's on our website. I've given away that whole page, which is a tabular form of everything that's in the book. And I've assembled it in terms of the topic, what it does, the name of it, in other words, what it does, and the page number. So you can see as far as if there are, and I believe there are vacuum engineers out there, quantum vacuum engineers, that are emerging, they're graduate students or undergraduates, that know this is the future, this is what we need to study, and what are the tools that will eventually go into a handbook.
Sure.
So when you look at those, for example, Fabrizio Pinto's one fellow, a PhD from JPL, who apparently Eric Davis knows nothing about, and yet he's published in PhysRev, designed the Casimir motor, mentions free energy in the abstract of his PhysRev article, and has a couple patents on the device. And what's fascinating about it is he does all the thermodynamics to rigorously do exactly what Eric is proposing to do, and he's already got it in print. And he shows that the engine works because you vary the dielectric constant of the cavity by turning a light on.
Oh,
a micro laser. Well, that's a trick you find in the Casimir world. There are lots of tricks like that change boundary conditions, make nature behave differently instantly.
I think this is one of the real values, though, of Integrity Research Institute, because it's been around for quite a while, and you do an excellent job as kind of an infrastructure resource, and I think that's so important these days in terms of we have no shortage of scientists, inventors, people working in their garages, but the real challenge has been finding the resources to bring them together and allow them to share and grow from each other's knowledge. So this paper would really serve as an example of that, I guess.
Well, the paper you're talking about is...
we'll mention the free energy paper that you've been able to find. Just really access the information knowing it's out there.
Well, these are journal articles I'm referring to, so certainly there's plenty of those that tap into or cite various properties of the vacuum that I believe are actually usable. For example, one of the hot topics in zero point is the emergence of molecular diodes. Nanotechnology now has a whole list of different molecular diodes that are showing very interesting properties for not only rectifying electricity or electron flow, but also being susceptible to the vacuum fluctuations. So you get a noise contribution from the vacuum, which is measurable, and also you get a single direction flow of electrons.
Oh, okay.
That, of course, is usable for creating energy.
Yeah, so the zero-point energy is definitely also on the upswing in addition to the breakthrough propulsion.
Right.
Well, another area that we're beginning to hear rumors about is possibly another high-frequency gravity wave conference. And I know this is an area that you followed somewhat, and I'm wondering if you have any thoughts about this area of research, especially in light of the many presentations by Robert Baker and others on HFGW applications.
Yeah, actually I did follow some of that, but to tell you the truth, creating gravity waves in the lab I think is a little bit too far in the distance to be practical. But I relate in that realm the work that Paul has done with impulse generator, gravity impulse generator.
Definitely.
And to me that is a much more practical application rather than necessarily think about gravity waves as communication mediums or something like that. Here's Paul looking at the mechanism to create a collimated force beam. And what's fascinating to me is that it follows the same electrokinetic force equation of Jefimenko's, so that you can at least explain where the force is coming from.
Sure.
And also, I've been proposing to lots of people that this is probably the most viable method, especially if it's researched and improved upon, to repel asteroids, to perhaps even, with a number of them, to work on incoming tsunamis, and who knows what other applications we might find from projectable force.
Yeah. Well, and again, having mentioned the Jefimenko equation, I think that one of the things that people can take away from Electrogravitics II that I definitely did was that it's a good intermediary between the hands-on and the theoretical. So it has the equations, but it also has them in an engineering format that the layperson working in their garage or working after hours in their den can actually apply those, unlike, unfortunately, some of the more esoteric physics that really, very few people have the capacity to do. So.
And also we put in some of the historical documents that are hard to find.
Yeah.
I found the Herald Tribune articles on gravity, the How I Control Gravitation article by Townsend Brown from 1929. Even I was able to get Jean Manning's article on anti-gravity on the rocks. And her essay is beautiful. It's a very good short biography of Townsend Brown, with a lot of little tidbits I didn't even know about, so it's a good resource.
Okay, well, thanks again for your time, Tom. I sincerely appreciate it, and on behalf of our audience, we'd like to thank you, again, for attending STAIF, for the presentation, and for helping bring this amazing 2006 event together.
Well, my pleasure.